Hello and welcome to another one of D's ADD videos. Today we're going to be looking at this example here, trying to solve for the particular solution of the following differential equation. So try to pause this video and try to do it on your own first, and then watch the solution, make sure you got the right answer. If you did, then you don't actually have to watch the steps if you feel comfortable with it, but if you didn't, go back and watch the steps and practice some more. Alright, so this here is a Bernoulli equation. You can tell because y's are hanging out with the x's over here on the right side. You can tell because y's are hanging out on the right side with the x's. Typically the only other y's right here if it's a non-separable. So what I do on these is I divide everything by the y term that's on the right of the equal sign. And when you do that, you get this. And what you're going to do is you're going to substitute this for another variable. So v is what I chose. Whatever you choose is fine. And then derive that expression with respect to x. So if the derivative of v is 1, implicitly derived with respect to x, it gives you a dv dx. Anytime you derive any variable that's not an x, you multiply by d whatever dx. Right? Derivative of v variable with respect to x. And here you derive this, so bring down the exponent, subtract 1, and then because this is not an x, I multiply by dy dx. Right? Derivative of y variable with respect to x. Now had it been 2 or x to the negative 2, this would be derivative of x variable with respect to x, and they'd cancel. All right? Implicit derivatives, go back and review it if you need to. So here, what we're going to do is we're going to try to solve for this expression here, the y cubed, y to the negative 3 dy dx, so that we can plug in terms of v. When we substitute, this becomes the negative 1/2 dv dx. This is my v, and this stays the same. All from here and here. Multiply, at this point, it's a non-separable equation. If you remember, this has to be a 1. So we multiply everybody by negative 2. So this is our new equation. We then find our integrating factor mu. So if you remember, integrating factor is e raised to the integral of p of x dx, and p of x is whatever's attached to this variable here. So integral of negative 2 is negative 2x. You get e to the negative 2x as your integrating factor. Now we plug into the non-separable differential equations formula. So 1 over the integrating factor times the integral of the integrating factor times q of x, which is everything to the right of the equal sign, dx plus c. So here, when we plug in, you get that. You should recognize this as integration by parts. Furthermore, you should see that this u term will eventually drive to 0. So that means that we can use the tabular method, and it'll go much quicker if we do. So in the tabular method, you let u equal one of the two. If you remember, I-late for preference of u, inverse trig, logarithm, algebra, trig, and exponential. So algebra beats exponential for u. We plug in, we derive until we get 0, integrate the same number of times, multiply diagonally, plus minus, plus minus. If this is not making sense, you need to go back and review your calc concepts of integration, derivatives, maybe some trigonometry, because you're going to see that throughout this course. Diffie-Q itself is not that hard, but if your foundation is not solid, then you're going to have a tough time in this course. So now we integrate that and plug in this here and simplify a little bit. Negative 2's cancel, 2's cancel, and you get that. Now we want to distribute that term here, and when you distribute, you get this here. Here we got some initial conditions, x is 0 and y is 1, so you plug in 0 for x and 1 for y. Oh, I'm sorry. First, I brought this negative exponent up. Anytime you have a negative exponent, you just switch it. If it's on the bottom, make it go to the top and change it to a positive. If it's on top, make it go to the bottom and change to a positive. So if we plug in a 0 for x and 1 for y, we get c is equal to 1/2. Once we get that, we can just plug back in what c equals, and there's your particular solution. All right? Again, we knew it was Bernoulli because the y was over here with the x. Typically, we don't see that. Only y we see non-separables are right here. So then at that point, we know it's Bernoulli, so we got to divide everything by this y cubed, do the substitution, find the derivative, so we can substitute the dy dx term here, and then it's a non-separable equation, multiplied by negative 2 everywhere. You get this here. Find your integrating factor, which is e to the integral of this. Well, it's attached to the v, so you get that. And then we plug into the formula, integrate. It was integration by parts. Look up the tabular method if that was confusing. Simplify, and then find your c using your initial conditions. X is 0 when y is 1. Find c, plug it back into the general solution to get your particular solution. All right? I hope I've clarified things enough for you to try these. They're not too bad. If you do a few of them, you'll see that you can see the pattern pretty easily. All right? But it does take that work. You got to put in the effort. It doesn't magically come into your head. So I wish you the best of luck. Thanks for watching. Have a great day.